Little isn't equivalent to nothing, and without a doubt, Canadian stargazer Paul Weird has now arrived at the resolution that the likelihood of impact for the space rock Apis is higher than previously suspected. Essentially, the 350-meter-wide shot will pass near Earth in April 2029, well, given that its direction remains unaltered up to that point, obviously. Yet that is exactly the core of the matter. According to Weird, even a crash with a little item could be sufficient to send Apis off on an awful path. The reality that we couldn't weigh up the genuine risk right now makes the situation no less precarious. Sadly, the space rock won't return into our field of vision until 2027. In the event that you like, Apis holds two records. From one viewpoint, the space rock came to the most elevated value ever on the Turin risk scale in 2004. And on the other hand, as an alleged executioner space rock, it also set off record-breaking media madness. Found in June 2004 by Roy Exum, David Geach-Thalin, and Fabrizio Bernard, the space rock immediately pulled in the unwanted attention of being on an impact course with Earth on April 13, 2029, a Friday the 13th, no less. The corresponding impact likelihood was estimated at 1 in 37, or 2.7%, and this didn't just apply to April 2029 but also to the years 2036 and 2068. Luckily, anyway, the media and cosmic situation has long since eased. Once again, thanks to detailed follow-up observations, it's now even thought to be unthinkable that Apis will come into close contact with our natural home in 4 years. Well, unless something occurs in the next few long stretches of time that in a real sense loses the space rock's course. However, favoring that later on, the reality is certain that even in the worst-case scenario, our Earth would have a fortunate break. As such, regardless of whether Apis were to slam into Earth, the effect wouldn't release a global calamity like the space rock impact that introduced the finish of the dinosaurs millions of years ago. The object, with its width of 350 meters, is essentially too small for that. Albeit, on the other hand, this does not imply that the outcomes of a direct hit wouldn't be lethal. According to the specialists, the impact crater alone would obliterate a region of several kilometers in width, and the power of the impact would be sufficient to obliterate an area the size of Central Europe. Communicated in calculations, this amounts to nothing less than that Apis would release an energy of 900 million tons of dynamite, which is, in turn, multiple times greater than the horrific power inherent in the nuclear bomb dropped on Hiroshima. But to influence the whole Earth's surface, it would require another multiple times more energy. The specific outcomes of a speculative space rock impact would depend essentially on where the object raises a ruckus around town. If the space rock were to collide with the ocean as opposed to the mainland, it could cover the nearby coasts under a beast tidal wave over 100 meters high. What could prompt an impact? Yet, luckily, we can now oust such discouraging considerations from our minds since, as I said, past direction observations have shown that Apis will pass extremely near our home planet. By each hair's breadth in this cosmic setting, it means a distance of more than 30,000 kilometers. So the 2029 space rock will still pass underneath the geostationary orbit. But at the end of the day, the all-clear given by the analysts still has a little proviso. We will only get the green light on space rocks if nothing unexpected occurs between now and then. At the end of the day, Apis will just miss Earth if it keeps up with its ongoing direction. What's more, strictly speaking, this is no more the case. A couple of years ago, researchers found that the radiation pressure of the Sun moves the space rock's orbit by around 170 meters every year, and although this deviation isn't sufficiently significant to coordinate Apis toward Earth in 2029, it might still lead to an impact on a later entry. And most importantly, this is by no means the only risk. Paul Weir, a specialist in orbit computations at the University of Western Ontario, warns that even the best current projections can't preclude the likelihood that Apis will be hit by a smaller object during its journey through space. Yet how large would the object need to be to thump a 350m piece off base? Well, most likely, it's essentially more modest than you suspect. After all, in the fall of 2022, NASA astonishingly showed how the orbit of a larger object can be effectively controlled by the designated effect of a fundamentally more modest one as part of the DART mission. The autonomous shuttle had gone about as a flying battering ram, crashing into the outer layer of the 165 m wide space rock, moon Didymos. In any case, while this astronomical diversionary move was just a test run, under real circumstances, such a hit could have substantially more serious outcomes. Weir states that even an impact with a small space rock, like those that routinely hit the Earth, could move enough energy to redirect its orbit. Considering this, the specialists are encouraged to watch out for the space rock, and they would most likely do so, even if they may still not see it at the moment. As a matter of fact, Apophis, US, disappeared from our field of vision as early as 2021, and since it is currently moving near the Sun, it appears undetectable even to the most powerful telescopes within recent memory. This will not change until 2027. But what happens in the interim, and whether Apophis may change its orbit during that time, is beyond our insight. Up until that point, since our galactic observations were essentially blind, we chose to examine the risk of redirection through a model simulation and figure out what sort of push would be required to put Apophis on a dangerous course while it's imperceptible to us. Past examinations had already shown that the space rock's direction would need to be moved along the side by around 200 kilometers for it to enter the keyhole. This refers to the small zone in the area of Earth where the Earth's gravitational pull would divert the space rock in 2029, such that it would adjust its direction to head for the planet during its next flyby in 2036. In this manner, we came to the similarly sobering and astounding conclusion that even a crash with an object only 60 centimeters across would be sufficient to poke Apophis through the keyhole. Communicated in numbers, the crash would change the space rock's speed by around 3000 ths of a meter per second, thereby clearing the way for the expected 200 kilometers shift in its orbit. If Apophis hits us as early as 2029, however, a fundamentally greater force would be required to be more exact. The space rock's flight speed would need to change by around 0.05 of a meter per second, or, in other words, it would need to impact with a 3.4 meter wide object. But the simple effect wouldn't be enough. According to Weir, it would also need to happen at a very specific time and bearing. But how likely is such a situation? Well, on a basic level, around 140 objects of 60 centimeters in size hit the Earth annually, and on average, only one object of 3.4 meters in diameter. However, since Apophis's cross-section is considerably smaller, the impact rate is reduced. Also, and most importantly, the likelihood of the space rock getting into the keyhole because of a hit is only one in many. The risk of a crash in 2029 is even lower, which puts the likelihood of Apophis being hit by a 3.4 meter wide space rock at only 1 out of 100 million. And considering that just 5% of such hits are related to a conclusive motivation, the likelihood for this case is even under 1 in 2 billion. Thus, the risk of impact can without hesitation be described as extremely low. However, tragically, extremely low doesn't mean zero. As things stand, we can't totally preclude an impact, and if chance really does strike, all our numerical expectations will no longer be very useful to us. One way or another, the specialists are well advised to gauge Apophis's direction as precisely as possible after it returns into our field of vision in February 2027. Then, a deviation of more than a couple tenths of a second could show an aggravation of the orbit. However, this would not necessarily imply that the space rock is on a crash course with our home planet. What sometimes gets pushed out of the spotlight, despite all the impact considerations, is the fact that Apophis isn't just a potential risk but also a tremendous source of information. On average, a rock of this size cruises by only once every few decades. So, scientists are faced with a rare opportunity to study a near-Earth object up close, and not just from Earth-based observation stations. In fact, specialists are already developing a small satellite that will accompany Apophis during its flyby of Earth and provide us with new insights. Thus, we would be able to give you new recordings routinely. Kindly go ahead and tap the subscribe button now so we can keep you updated from this point onward. We'll look forward to having you join our community.